Hi everyone, so welcome to my class. This lecture is going to be more about derivatives and differentiation. So we will learn how to differentiate a function, okay, how to differentiate a product, okay, like suppose two functions are given in product, so how to differentiate that. Uh, so we have already started the differentiability and I talked about the concept of derivatives and then I introduced continuity concept as well as some part of the limit as well. But I will be coming back to the limit concept again because we need the strong foundation to be able to compute limit of a function, right? So your derivative concept must be very strong, right? So there are various ways we can differentiate a function. Okay, so I will be discussing those methods, right? So however you might be familiar already those concepts, but I'm just going to give you the kind of revision you can say, and I hope you might find it new and innovative way of learning, right? So and this is going to be you can say more about derivatives, more about you can say derivatives, okay, and differentiation. Understand? So how to differentiate a function, that is very important. Differentiation, right? Okay. So this is nothing but lecture number 12 we can say. So generally we say that one theorem we can quote here. Theorem, it is nothing but a theorem you can say. We most of the time say that differentiability implies continuity, or you can say differentiable. We can say that differentiability implies continuity, right? Implies continuity of the function, right? So if the function is differentiable, okay, if the function is differentiable, we say that the function is going to be continuous, okay? So this is one important theorem that you have to remember. But in words, right? That's it, okay? If somebody is going to ask you, can you prove it? So you will say, sir, the proof was not taught to me, right? Okay, so in the interview, they might ask you, differentiability implies continuity. Okay, so not other way around always. Like continuous functions are not always differentiable. Okay, there are some exceptions like mod of x. Okay, so I have told you also while discussing the free calculus concepts. So this is one theorem that you have to remember. Okay, so I will get back to differentiation very shortly, but I need to discuss this theorem, right? So differentiability implies continuity. How to prove this, right? So we can prove also this. A very simple proof I'm just going to give you, right? You will not find this kind of a proof. People who teaches gate, right? So they do not discuss all these things, but I'm just going to explain you. So differentiable implies continuous, or you can say differentiability implies continuity. So you can say that if the function is differentiable, if the function f, you can say, if the function f of x is differentiable, okay, if the function is differentiable at a point, you can say at a point x naught, right? So we always find the derivative of the function at certain point, right? So you can say that if f is differentiable at x naught, okay, at that point, then the function is continuous at x naught. Then the function f of x is continuous at x naught, right? So this is just a statement that we have given here, right? But what should be the mathematical proof that you need to understand? So you can recall the definition of differentiability, right? So you know the definition of differentiability. What is that differentiable? Okay, so you need to recall that. Okay. So, or you can say also that what is the definition of you can say mathematical definition of continuity? So we say that limit x tending to x naught or x approaches x naught f of x must be equal to what? the value of the function at x naught, right? This is the definition we call it. Okay, so what you can do here is you can take this f x naught this side, right? So I'm just going to take this. So I'm just going to rewrite this as x tending to x naught fx minus fx naught. So we can take this guy this side, and we can take it is as a whole entire limit, you can say. Okay, I'm just going to put inside the parentheses, okay, or inside the bracket. Okay, so what we have written here is that fx minus fx naught. So we are subtracting the function, right? Okay, fx minus fx naught. So I hope this makes sense. So you can write like this. Then what you can do here is you can divide and multiply by x minus x naught, right? To give an expression. So you can write this as different limit x tending to x naught. Okay, limit x tending to x naught. Okay, then you can write this as fx minus fx naught upon divide by x minus x naught and multiplied by x minus x naught, right? I hope this makes sense, right? So you can do this. This is simple manipulation that we are doing. Okay, मैं ऐसा क्यों कर रहा हूं? Just want to prove differentiability implies continuity, right? अब देखो यहाँ पर है क्या कि ये वाला जो टर्म है फर्स्ट टर्म, फर्स्ट टर्म इज द डेफिनेशन ऑफ दैट फर्स्ट टर्म इज नथिंग बट डेफिनेशन ऑफ व्हाट, द डिफरेंशिबिलिटी, राइट? ओके, ये डिफरेंशिबिलिटी की डेफिनेशन होती है, ठीक है। और ये वाला टर्म क्या है? अगर x रखते हो यहाँ पर, इफ यू पुट x हियर, राइट, आई मीन इन प्लेस ऑफ x इफ यू पुट x नॉट, राइट, सो इट बिकम जीरो, राइट? सो ये इनडिटर्मिनेट है, दिस इज इनडिटर्मिनेट फॉर्म, राइट? रिमेंबर दिस, ओके? You cannot divide by zero. Okay, please, this is one of the important fact you have to remember. So you can write this as, this is the definition of what? F dash x naught, right? And you can also apply the limit here. Okay, there are some algebra of limit that I will discuss also. Suppose limit x tending to a f of x times g of x is given. So you can write this as limit x tending to a f of x times limit x tending to a g of x. This is from the algebra of limit. Okay, so if there are product of two functions and you are finding the limit, you are applying the limit x tending to a, so you can take the limit of individual functions, right? This is from the algebra of limit. I will discuss this, right, once I will come back to limit. So this is from the definition of differentiability times, अगर इसमें आप लिमिट लगाते हो तो ये क्या हो जाएगा? जीरो हो जाएगा. Okay, and that becomes what? Zero only, right? Okay, so you see here, guys, this becomes zero then. So this is proven. Limit x tending to x naught fx minus fx 0, right? That is going to be 0, right? So you can say that limit x tending to x naught, and this is just a a function value. So this is proven, right? So now it is proven that differentiability implies continuity. Okay, differentiability implies continuity. Please do remember that. Okay, so the very first step is what? You need to divide and multiply by x minus x naught. Okay, then if you put directly x equal to x naught, then what you are doing? You are multiplying with 0 by 0 times 0. Okay, understand? So remember that x minus x naught is not equal to 0. Please keep in mind this, right? X tending to x naught, where x is not equal to x naught. Okay, so we are just applying the limit here. So this is just a definition, right? I mean, this is just a small proof. आपको याद रखना है, ये एक सिंपल प्रूफ मैंने आपको बता दिया, ठीक है? तो आई होप यू विल अप्रिशिएट दिस प्रूफ, ठीक है? प्रूफ मैंने कहाँ से स्टार्ट किया आप देख सकते हो. मुझे राइट हैंड साइड जीरो करना था बस, एंड आई मेड इट जीरो, ठीक है? नाउ लेट अस कम बैक टू द डेरिवेटिव्स. ओके, डेरिवेटिव्स. सो in today's session I'm just going to cover few topics like derivatives of the product, right? Derivative of the product, quotient, okay, derivative of sin x and derivative of cosine x and many more things, right? So these are the concepts we are going to cover. So if I recall the derivative formulas, right? So you can recall the derivative formulas, okay? How to differentiate a function, that is very important, right? So we will recall here the derivative formulas. We can put it as a derivative formula, okay, formulas. So the very specific, you can say, to be very specific, you can say that f dash x. What is f dash x? F dash x is nothing but the differentiation of function, right? So if you have got a function of this kind, you can say that f of x is given as x to the power n 1 by x, right, and so on. This kind of a function is given. So what will be the general formula for this, right? What is going to be the general formula for this, right? So I mean, they might ask you what is dy by dx x to the power n, what is dy by dx 1 by x, right? So you should know directly the formula for these, right? So that okay, understood. So this is one important fact that you have to remember, right? So if you know the formula, you can directly differentiate it. You don't have to use the definition of differentiability, okay, that I have told you, right? So this is one, and one general example that suppose there are two functions, okay? Suppose there are two functions which are added, right? Okay, so suppose in general you can say that in general, suppose there are two functions u plus v, and you are taking the derivative of this. So you can individually take the derivative u dash plus v dash, right? You can also write this as dy by dx u plus v, so which is nothing but dy by dx u plus dy by dx v, right? Okay, this is the sum, okay? In general, suppose two functions are added, right? So you can differentiate them individually, okay? That differentiation of overall function is going to be, you can say overall combination is going to be the derivative of individual functions, right? Or suppose any function is given u, and if you're multiplying by constant, okay, and if you're taking the derivative of this, so constant will be taken out and it is nothing but u dash. Or you can also write in terms of dy by dx c times u, okay, which is nothing but c outside ho jayega, dy by dx u, okay? So always remember constant will be coming out, right? Okay, so you can take the example, guys. So many examples are there that you can take, right? Okay, so I hope this makes sense. So these are the formulas that you have to I mean, I will be talking about. Okay, so the very important is u plus v. U is nothing but a function of x, you can say, right? Here I am taking u of a function, okay, v is nothing but a function of x, right? So these are the two functions that we can add, we can subtract, we can multiply, and we can divide. So what are the operations that you can perform? Suppose you have got u of x and v of x, okay, so what are the combination which is possible? So you can add two functions, right? You can subtract two functions, you can multiply two functions, right? You can divide two functions. So these are the operations that you can perform. Also you can find the derivative of them. So ये तो शुरू वाले तो बहुत easy हैं. These are very simple, right? But how to differentiate two functions when they are given in product, right? That is the question of the day, right? How to differentiate a function when two functions are given in product, right? So that is what I will be answering for today. Okay, so you don't need a proof. If you need a proof, I will share the proof as well, but you don't need a proof all like u plus v equal to u dash plus v dash. You can also prove that. So I think it is not needed. Okay, Okay, and derivative of sin x and cosine x, they are very specific. Okay, so that also you can prove it, but you don't need a proof, right? So you have to always remember only for simple calculation dy by dx. Suppose sin x is there, right? So sin x का differentiation होता है cosine x, and if you're differentiating dy by dx cosine x, so remember it will be negative of the sin x, right? Okay, ये please do remember directly sin x का differentiation cosine x and cosine x का differentiation minus sin x. So you have to notice here it is a negative slope, right? So why it is coming out to be negative? When you draw the plot, right? Okay, when you draw the plot, there are negative slopes, okay, that you will find. Okay, so understand. So I will show you everything. So negative, this negative sign indicate there is a negative slope, right? The function is decreasing. Fine. So basically, you don't need a proof, right? Okay. So dy by dx sin x is nothing but cosine x, and dy by dx cosine x is nothing but minus sin x. Okay. In case of derivative, please do remember this, right? And you don't need a proof, as I said. Okay. So now I will talk about product. Okay, product formula. So what is this product formula? Product formula. So suppose you have got u times v. I prefer to write in terms of dash, u v dash, right? You can also write this as dy by dx. Assuming that u is a function of x only, right? So u times v. Okay. So you can prefer any notation, guys. There is no problem. So u v dash, right? So first of all, what you can do here is you can differentiate first function u, then keep second function as it is, plus you just keep first function as it is, differentiate second function. So this is the formula for product of the derivative of the product, you can say, right? Derivative of the product. Okay, derivative of the product. Okay, what I have told you, take first function. Okay, take first function, right? And then differentiate it, keep the second function as it is, don't differentiate, don't do any disturbances to second function. Okay, understand? So this is the strategy that you have to use. Okay, so this is just a formula. Okay, if you remember the formula, you don't need a proof also, guys. You can prove it by using the differentiability formula, but needless to prove at this moment. Okay, when you will go to IITs and ISC, there you can prove it, right? But needless to prove at this moment. But if you need a proof, you can contact me, right? So I will share the proof as well. Okay. So proof takes, I mean, there is no use of proof here, right? And suppose there are quotient formula, right? Suppose in general you can say that this is called quotient formula. Okay. Quotient formula says that suppose you are differentiating a function u v dash, u by v dash, right? Suppose two functions are given and they are given in quotient, right? They are given in ratio form like u upon v. So how to differentiate this function? So what you have to do here is you have to this denominator second function is in the denominator, right? You know, so second function means you have to differentiate. I mean, you don't have to differentiate this. You have to take the square of the second function, v square. Okay, you have to take the square of second function, right? V square, and then take the first function, differentiate it, take the first function, differentiate it, minus okay, keep second function as it is, right? Keep second function as it is, and then what you can do here is then keep first function as it is, second function differentiation. This is the situation. You can also write this as first by second. So second function, first differentiation, second as it is, second differentiation. That's it. Okay, this is the general formula for quotient, guys. Again, you don't need a proof here, right? जहां proof की जरूरत होती है, there I will be telling proof. Okay, wherever you need a proof, I will be telling you the proof, right? Wherever you don't need a proof, I will not tell you the proof. ठीक है? So these are the product and quotient formula that I have told you. Fine. Now, if I say that, so after learning u plus b, u minus b, u v, and u by v, right? I will talk about chain rule. ठीक है. तो आपको कुछ बेसिक डिफरेंशिएशन आप समझ जाओ. I will take some example as well, right? So suppose we have got dy by dx, x to the power n. What is the formula for this? N times x to the power n minus 1. Okay, n times x to the power n minus 1. Okay, and you have to remember dy by dx sine x as well. So it is nothing but cosine x. You have to remember dy by dx cosine x, which is minus sine x. Okay, so these are the formulas. Please do remember. Okay, some list of the basic differentiation of the function. And if you're differentiating dy by dx 1 by x, right? So you can write this as dy by dx x to the power minus 1, which is nothing but minus 1 x to the power minus 1 minus, so it is nothing x to the power minus 2, and you can write this as 1 by x square, right? So differentiation of this is this, using this formula, right? Okay, using this formula you can do this. Okay. UB and you can see u by v. We will take some example as well, but for the moment let us discuss concept first, right? So now I will talk about chain rule. Okay, chain rule. ये भी बहुत important है, chain rule and higher derivatives. What is the meaning of higher derivative, guys? Means one time differentiation you have done, okay? Then again, if you want to differentiate second time, that is called second derivative, right? One time differentiation, second time differentiation, third time differentiation, fourth time differentiation, right? So you can differentiate n number of times, right? Right? So you need higher derivatives, right? In the calculus, single variable calculus, okay? Or multi-variable calculus, you need higher order derivatives, right? Okay? Because in future you will learn the application of derivatives. आपको application of derivatives सीखना है. So you need higher order derivative, like first order, second order. First order is, okay? Second order, third order, fourth order, fifth order, right? So you need to differentiate a function n number of times, right? ठीक है. So see, we got the general procedure for differentiating expression like addition, subtraction, multiplication. ठीक है. तो अभी तक हम लोगों ने क्या सीखा कि we got to see general expressions, right? General expression, okay, or you can say general procedure. General procedure, right? Okay, for u plus v, u times v, and u by v. Okay, understand? You can write this. But if I ask you, okay, so these are addition, multiplication, and quotient. Okay, but if I ask you, or you can say if I ask you how to differentiate a composite function, my question is how to differentiate a composite function. देखो मेरा क्वेश्चन क्या है ये समझो पहले. हाउ टू डिफरेंशिएट अ कंपोजिट फंक्शन, राइट? सो डिफरेंशिएटिंग अ कंपोजिट फंक्शन मींस यू हैव टू यूज चेन रूल. ठीक है, यहां पर आपका क्या आता है, यहां पर यूज चेन रूल. अभी तक आप लोग ब्लाइंडली चेन रूल लगा रहे थे, बट कहां पर लगाना है चेन रूल? वेयर यू हैव टू यूज द चेन रूल व्हेन you have to differentiate a composition, or you can say composite function. Now the question is what is this composite function, right? ठीक है. Okay, what is this composite function, guys? Composite function क्या होता है, right? What is this composite function? Okay, so composite function is nothing but this. I'm just going to take this again. So I think everybody knows composite function. I have explained also, right? Suppose input is given as x, okay, and you are passing through a machine, okay, So composite function. So knowledge of composite function is important. ठीक है. So ये. Suppose x is passing through this, so you got this. Okay, you are giving input as x, so you got g of x. Now g of x is the input for this function. So this is nothing but f of g of x, right? This is nothing but a composite function, guys. This is a composite function, right? So how to differentiate a composite function? That is a question. Yeah, how to differentiate a composite function? That is a question, right? So let me say that notation you have to remember notation. Suppose you are differentiating dy by dt f of gt. Okay, like inside the function there is one more function. Inside the function there is one more function, you can say. So how to differentiate this? सबसे पहले क्या करना है? You have to differentiate a function, the outer side function. Okay, whatever function is given, like f. Okay, so you have to differentiate this f dash and keep gt as it is, right? Then you have to differentiate the function which is inside the parenthesis, inside the bracket, you can say, that is nothing but g dash t. Okay, so this is how we differentiate a composite function, right? Okay, this is how we differentiate a composite function. You can say that, suppose in terms of x I am taking, so this is f of g of x. Okay. So first of all, what you have to do here is you have to differentiate dy by dx f of g of x, right? Keep g of x as it is, right? But differentiate f dash, differentiate a function f, then you have to differentiate what? G of x. So this is nothing but a chain rule, we call it. इसको हम लोग क्या बोलते हैं सर? Chain rule. Okay, in chain we are differentiating, we are finding the derivative, right? So chain rule is needed to differentiate composite function. I think today you came to know why do we apply chain rule, because there are composite functions, right? So I'm just going to take some of the example here and try to explain you this chain rule examples, right? Okay, so what are the example that we need to understand is suppose we have got a function f, you can say, or by f of x, which is given as sine x, right? And suppose x is given as gt. Okay, gt, which is nothing but t square. Okay, understood. So now your function become what? See, by equal to f of x, which is sine x. Now x is given as gt. Okay, so this function is nothing but what? This function is nothing but, you can replace this, you can write this by as f of, in place of x you can write gt. Okay, understood. So this is nothing but sine, in place of x you can write what? Gt. So this becomes sine, okay, sine t square, right? Now what you have to do, you have to find dy by dt, right? So to find dy by dt, what you will do? You have to use what? Dy by dt, right? So dy by dt is nothing but what? Dy by dt. So directly you can differentiate now. So if you differentiate this sine t square, right? So differentiation of sine t square is nothing but what, guys? Cosine t square. Directly you can differentiate that. Next, differentiate t square, right? So it becomes 2t. So answer will be 2t times cosine t square. Okay, this is the, okay. So first of all, we are differentiating entire function, then we are differentiating the argument of the function t, right, with respect to t only. Or you can write this as, suppose you don't want to, suppose it is given here, अगर आपको अलग डिफरेंट तरीके से करना है, मैं आपको एक और तरीका बताता हूँ. देखो, suppose you don't want to write in terms of composite, okay, directly you want to differentiate, ठीक है, तो आपको क्या निकालना है सर? dy by dx, sorry, dy by dt निकालना है. So first of all, what you do, this by is nothing but a function of x, right? So differentiate this by in terms of with respect to x. So dy by dx times, right? Then differentiate this x with respect to t. So dx by dt. So if you cancel dx, you will get dy by dx. Yeah. So this is nothing but a chain rule. Okay. So here also you can say that this becomes cosine x, right, times dx by this is nothing but 2t. So what is x here, guys? In place of x you can put so cosine t square. So this is how also you can do. This is, you can say, method 2, right? And this is nothing but a method 1. तो मैंने आपको दोनों मेथड्स बता दिए, राइट, चेन रूल के, दैट यू कैन अप्लाई हियर, राइट. होपफुली दिस मेक सेंस. ठीक है. Okay. So remember, I told you also that the FOG, FGX and G of f of x is not commutative, right? Both are not same. ठीक है. मान लो एक और एग्जांपल लेते हैं, एग्जांपल नंबर 2. ठीक है. एग्जांपल नंबर 2. Suppose we have to differentiate dy by dx cosine 1 by x, right? What is this? So again, guys, it is a composite function, right? So first of all, if you differentiate this, so differentiation of this, you can say this is nothing but by. So dy by dx, okay, is going to be equal to, differentiate this first. So you can say that it is gonna be minus sine 1 by x. Cosine ka differentiation minus sine 1 by x. 1 by x will be as it is. Now you can differentiate 1 by x. What is the differentiation of 1 by x? That you know, that is nothing but minus 1 by x square. So if you multiply this, so minus minus plus, so this is nothing but sine 1 by x and 1 by x square. यही आपका आंसर है. ठीक है. Hopefully this makes sense. Right. So hopefully this makes sense. So this is nothing but your g of x and this is nothing but your f of x. So first you are differentiating f of x, then you are differentiating g of x, and by chain rule. Okay, by chain rule. Okay, so 1 or 2 times if you will watch it, you can learn it, right? So please do remember that. I hope this makes sense. Okay, so dy by dx x to the power minus n is, someone is going to ask. Example number 3. Dy by dx x to the power minus n. So it is nothing but what? Minus n x to the power minus 1, right? I mean minus n minus 2. Formula, it is a direct formula. Okay. This is just a direct formula, you can say. Please do remember this. Okay. So chain, I hope you understood the chain rule, right? So now I will talk about concept of higher derivatives. Concept of higher derivatives. What is the meaning of that? What is the meaning of higher derivatives, right? So higher derivatives are the derivative of the derivative. Higher derivatives are what? The derivatives of derivatives. Okay. Higher derivatives are nothing but derivatives of derivatives. Suppose you have found out the first derivative, again you are taking the second derivative, so you are finding the derivative of the derivative, right? Okay. So suppose you have got a function g. If suppose g is nothing but f dash, okay, function g is nothing but f dash. So what is this h? H is going to be g double dash. Sorry, g dash. G dash is nothing but what? F double dash, right? We call it second derivative. This is nothing but second derivative. Second derivative means f dash already tha, again you are finding the dash, right? So dash here is nothing but derivative, right? So you can find out the derivative, right? So second derivative. So first So let me talk about the notation here, guys. Notation is important, right? So if you are finding the first derivative, f dash x, suppose given a function f of x, which is continuous, yeah, and differentiable as well. So f dash x is nothing but the first derivative. You can write this notation, or you can also write df like this, because first derivative means d times f is the first notation it is. Or you can also write df by dx. Now second time, if you are going to differentiate, so you can write this as f double dash x. Okay, this is called second. It is the first derivative. Second derivative. Okay, so you will write d square f, or you can d2 by dx square. These are the notation to remember. क्योंकि आपके सिंगल वेरिएबल में व्हेन वी विल टॉक अबाउट मैक्सिमम मिनिमा कॉन्सेप्ट, और यू कैन से लेट्स से ऑप्टिमाइजेशन प्रॉब्लम इन कैलकुलस, so we are going to use how to optimize a function. So we are going to use these second order derivative concepts or first order derivative concept, right? So please do remember these notations. I'm just going to use any of the three notations, right? Okay. Second derivative, third derivative, तो d3f. ओके, अगर d क्यूब f लिखा है मतलब थ्री टाइम्स डिफरेंशिएशन ऑफ द सेम फंक्शन. ओके, and so on. Okay, so you can differentiate. Okay, you can differentiate this n times. You can say that f n x, this is n time differentiation, or d to the power n time differentiation of the function f, or dnf by dx to the power n. ठीक है, hopefully this makes sense, right? So what I told you here, higher derivatives are pretty straightforward, right? Just keep taking derivative, right? Don't stop. Okay, don't stop. As I said, don't stop, guys. Okay. If you're going to stop, then life is understand. So please remember, these are very straightforward concepts. So I'm just going to show you one important, and, okay, so one example here, and this is, you will find some pattern here, right? And it is magical also, right? And the result is gonna be one of the very important concept which we use in permutation and combination as well, right? So you will see. Suppose we are differentiating x of n. How many times? N times. Matlab dn x to the power n by dx to the power n, or you can also write this as f to the power n. Okay, like a function is there, right? It is being differentiated how many times? N times, right? Okay, n times. So differentiate a function n times. What is going to be the result? And x to the power n is nothing but a kind of polynomial, you can say polynomial function. So कोई पूछता है कि d n times अगर आप x to the power n को differentiate करेंगे तो क्या आएगा? What result you are going to get? Okay, so in general you should know this, right? In the interview they might ask you. So since they are asking n to the power n, the order, the degree of the polynomial is n, and you are also differentiating n times. The degree as well as the order of the differentiation is same, right? So we can start from the lower degree, right? Like we can say that what is differentiation of so that we can look the pattern, right? So start from the small, and look the pattern. That is the idea. So you can start from the small, like if you're differentiating x one time, right? So it is going to give you 1. Suppose you are differentiating x square, right? 2 times. So if you differentiate 1 times, you will get differentiate x square 1 time dy by dx. तो क्या मिलेगा? 2x. अगर आप फिर से डिफरेंशिएट करते हैं इसको तो क्या मिलेगा? You will get x only, right? Hopefully this makes sense. ठीक है? So I mean you will get 2 only, not x. You will get 2 if you again differentiate that. ठीक है? So one time differentiation. Okay, if you differentiate 1 time, right? तो इसका मतलब क्या हुआ, इसका मतलब हुआ कि इसको डिफ्रेंशिएट करिए, एक बार डिफ्रेंशिएट कर दिया, अब ये क्या देगा, this is going to give you 2, and this 2 can be written as 1 times 2, right? Can be write like this, 1 times 2. Okay, this dot, it is not a dot, it is nothing but a multiplication, you can say. Now if we are differentiating 3 times x cube, तो इसको हम कैसे लिखेंगे, d square, okay, d square 3x square, right? Then d times 6x, right? Then it is gonna be 6, and 6 को कैसे लिखेंगे, 1 times 2 times 3. I hope this pattern are you are able to observe, right? So 1 times 2 times 3. Now next, d to the power 4 x to the power 4. So I'm just going to write directly, right? So इसको आप 3 times differentiate करेंगे एक बार करने के बाद, 4 to the power 3, then 2 times differentiate करेंगे 12 x to the power 2, then इसको एक बार करेंगे तो 24x, then ये 24 आएगा, which give you 1 times 2 times 3 times 4, right? Hopefully this makes sense. So if you're going to, what is this? So if you're going to differentiate n times x to the power n, so what you're going to get, guys? What you're going to get? You're going to get, see, you're starting with n, with n minus 1, n minus 2, right? So you are starting like this, n minus 1, n minus 2, and so on, and you're reaching 1. What is this? This is nothing but n factorial. So if you take a polynomial function and differentiate n times, so what is the answer for this question? D n times x to the power n will give you n factorial, guys, and this factorial concept is one of the important concepts. Okay, the factorial, I think this is understood, right? Okay, so you have to differentiate n times. Okay, suppose you are differentiating n plus 1 times the function x to the power 1, so these should match, they must match, right? So what is the answer for this question? Answer for this question is going to be n plus 1 factorial. Now you don't have to remember anything. Suppose you have to differentiate x to the power 4, so what is the answer? 4 factorial. Don't waste your time, right? Directly you can say, okay? Directly you can say 4 factorial. Suppose someone is going to ask you what is the differentiation of d 10 times x to the power 10 ka differentiation, 10 factorial. Okay. So I think this is a very rapid way of solving the question. If you observe the pattern, so maths में क्या है, pattern ही तो है, right? You need to watch the pattern. ठीक है? Okay. Understand? So please do remember this. Okay. Now I'll talk about one of the important concept again. ठीक है, इसके बाद ये तो आपको समझ में आ गया. अब एक और important concept है, मतलब these are the ways of differentiating a function, right? So we'll talk about implicit differentiation. Implicit differentiation, right? So this is also useful technique. Implicit differentiation, right? Implicit differentiation. ठीक है. So in fact I will take this implicit differentiation in the next class. Implicit differentiation and inverse. Okay, today only I will conduct the session and I will discuss this implicit differentiation. ठीक है. So implicit differentiation we will discuss, and we will also talk about logarithmic differentiation. Okay. So these are the topics that I'm gonna cover. Logarithmic differentiation. Okay. Understood. So these are two type of differentiation that we are going to talk, right? So stay tuned. We will come back. Okay. Thank you.